Okay, so today we're going to start chapter 4. We're going to skip lesson 1 and we're going right to lesson 2. This is what's on the quiz on Friday. You will have to graph 2 of the questions on the quiz on Friday. Then we'll spend 2 more days learning how to solve these exponential equations. So we've learned how to work with exponents at the beginning of the year. We learned all those rules when we multiply powers that have the same base, how to divide, the power to the power. All of those rules for exponents we can apply in this lesson. So these are examples of exponential functions. And what we're going to do for graphing, we're just going to make a table of values. We're going to plug in -1, 0, and 1. Now, when we plug in 0 into our exponential functions, what's anything to the 0 power? 1. So that order pair for all of these exponential functions is going to be the same. Unless we've got a negative exponent or a negative number as our base. This one would give us a different value when we plug in. But we're going to see that as we go through these. So here is our first example. And they're asking us to graph y equals 3 to the x power. Now, if you were to get out your calculator and key this in your calculator, just make sure that when you put in the x in your calculator, that it's as an exponent. One year when I taught this, I found that the student put in y equals 3x in their calculator, and then when they hit graph, it was a linear function. It was a diagonal line. So just make sure that if you are going to check your graphs tonight, that you're keying in the exponents. Yes?
Is it possible to make an exponent off the 3? Or no?
Off the 3? What do you mean?
Like, just take the square root of x on the 3, does that make sense? So we can get the exponent away on the 3. Is that possible or not?
Oh, no, we're going to be solving for x, and we're going to learn how to do that.
Okay.
Yes. All right. So let's go ahead, and the way that we're going to graph these is we're going to make a table of values. So we're going to plug in different values of x and get order pairs. The 3 main ones that we're going to always be using are the -1, 0, and 1. Now, just to show you, I'm going to do a few more here. I'm also going to do -2 and +2, just to show you what happens. Now, if you recall from the beginning of the year, when we have a negative exponent, it doesn't make the number negative, it makes it a fraction. So this would turn into 1/3, so 1/3. If I put in a 0, anything to the 0 power is 1. When I plug in 1, 3 to the first power is 3. And then here's my negative exponent again. It makes the whole thing go underneath a 1. And then I would evaluate 3 squared. And then here, 3 to the second power is just 9. Now realize that this little table here has now created order pairs for me. So the order pairs that I could graph are -1, 1/3, 0, 1, 1, 3, -2, and then 1/9, and 2 and 9. So I could take these order pairs. So now I'm going to go over to my coordinate plane, and I'm going to graph these points. So again, the one that's always going to be here is this 0, 1. I had the 1, 3, the 2, 9, the -1, 1/3, and -2, 1/9. Now, I do have a horizontal asymptote here. You guys recall this from before the break. My graph here is going to skim along the x-axis because that's where my asymptote is. Connect the points, and I have a horizontal asymptote here at y equals 0. All of your exponential graphs are going to take on this shape. Now they may be reflected across the y-axis, so they may go the other way. They might be reflected across the x-axis, so they'd be flipped down. And we're going to be shifting them left, right, up, and down. So let's try another one. with a different base, and you're going to see that it's going to take on this same shape. So if we go to the next slide, notice this time, instead of 3 being the base, I have a 5. Again, let's do our table of values. I'm only going to do -1, 0, and 1 this time. And you're going to see it takes on the same shape. So 5 to the -1 power is 1/5. 5 to the 0 power is 1. 5 to the first power is 5. So I'll take these 3 order pairs, put them on the graph. So I have 0 and 1, 1 and 5, and then the -1 and the 1/5. And again, approximate it. Again, we've got a horizontal asymptote again, which is preventing my graph from going below the x-axis here. So a horizontal asymptote at y = 0. And again, it took on the same shape. So the next slide has not an integer, but a fraction. So again, let's just do our table of values. And let's see what this graph looks like. Get a different color. So I'm going to do -1, 0, 1, and 2. Now, remember, when you raise a fraction to a negative exponent, think reciprocal here. So then this becomes 2 over 1 to the first power, which is just 2. So then this order pair is -1, 2. Again, anything to the 0 power gives me 1. Then 1/2 to the first is 1/2. And then 1/2 to the second power is 1/2 times 1/2, which is 1/4. So again, I can take my order pairs. Again, just make sure you're getting these 3 main order pairs on there. So again, let's graph these. So -1, 2, 0, 1, 1, 1/2, and then I can get that one on here. And again, you can see you still have that horizontal asymptote. It's just been reflected here. So here's my horizontal asymptote at y = 0. Next one. So again, I'm just going to do a table, but notice when I do this, you need to be very careful. This negative exponent, if I put in a negative number, negative makes it become positive. So again, what we're going to learn coming up is when there's a negative sign in the exponent, this is like a reflection across y. When the negative sign's in front of the base, it'll be a reflection across x. And we're going to learn about these shifts coming up in the next few examples. But again, right now, for now, all we need to do is make our table. Let's plug in -1, 0, and 1. 2 to the -1, and this becomes 2 to the first, which is 2. 2 to the -0, there isn't anything as a -0, so it's just 2 to the 0 power, which is 1. 2 to the first power, and I got a negative sign there, and this becomes 1/2. So now I can take these 3 order pairs and graph them. And you're going to see it's the exact same graph as y equals 1/2 to the x power. So let's go ahead and graph these. -1, 2, 0, 1, and 1, 1/2. Sign, if the exponent has a negative sign, that's going to indicate that it'll be a reflection across y. The next example, the negative sign is in front of the base. This is going to indicate that it's a reflection across the x-axis. This one, when you have a negative sign in front of your base, this is going to be a reflection across x. So when you go to graph this, if the points you came up with are not flipped over that x-axis, you know you've done something wrong. Now, be very, very careful when there's a negative sign in front of the base. Notice there's no parentheses around this. So when I go to do this, most of my answers are going to be negative because that negative sign is not being held in. So watch what happens when I make my table here. So x and y, when I plug in -1, 0, and 1, I'm doing -2 to the -1 power. This -1 exponent is only on the 2. The negative sign is going to drop in front of the answer. So this answer is going to become -1/2 because the -1 makes the 2 go underneath. Yes?
What would happen if it had parentheses there?
Then it would become positive. So if it were this, -2 to the -1 like this, then this whole thing goes underneath here. And then, well, actually, we're going to move the whole thing down, and it still stays negative. But if it were squared, then it would become positive. Yes. So this would still stay negative. But when it gets to -2, then it would be positive. Okay, so then let's plug in the 0. Now, again, the only thing that's being raised to the 0 power is the 2. The negative sign goes in front. So this becomes -1. And then -2 to the first, and that's also -2. So the 3 ordered pairs are -1, -1/2, 0, -1, and then 1, -2. So again, if I take my 3 points, -1 and -1/2, here and here, notice you still have the horizontal asymptote. It's just been reflected. Y = 0 is the horizontal asymptote. So if you were to have just done y = 2 to the x, then you would have gotten these order pairs. Plug in 1 and 2, and then you could have reflected this. If you would have just graphed this function, you could have gotten the 3 order pairs and then reflected it. But whenever it's just something simple like this, you're a lot better off just making a table for that and then doing the shifts from there. Now, this was the first graph that I did, example 1. So here is the graph down here at the bottom. This is the graph of y = 3 to the x power. Notice the graph that they're asking me to, or the function they're asking me to graph, is now y = 3x + 1. When something is added or subtracted to the base, that's going to be the shift up and down. So for add, it's going to be up, and if you're subtracting, it'll be a shift down. So this is to the base, yes?
Could we still just do the table?
Absolutely. Now, in the homework tonight, they're going to tell you what original function to graph. So for example, if this were your homework question, they're going to say graph this one first and then apply the shifts. So when you get to this part of the homework, you're going to have 2 different graphs. So what I would do is do a table for this one and then take the 3 order pairs and shift all 3 of them 1 unit up. So here is the original one that I did in the very first example, and I got these 3 order pairs. let me just show you again. So if I make my table and use -1, 0, and 1, 3 to the -1 is 1/3, 3 to the 0 is 1, and 3 to the first is 3. So I'm going to take these 3 ordered pairs, this, let me do it in red, this, and this, and now I'm going to take all 3 of these and shift them all 1 unit up. So I'm going to take the y-intercept, move it up 1, move this 1, I'm moving them all up 1 unit. And now I can connect them, and here would be my shifted graph. Again, notice my horizontal asymptote has now shifted to y = 1. Now, again, when it's simple like this, yes, you could do a table and just add 1 to the result that you get. Everybody good so far? Yes. I'm still comparing it to the y = 3 to the x power. So here, let's see. So whenever you add to the exponent, that's going to be a shift left. If you subtract in the exponent, or to the exponent, that would be a shift to the right. So again, just like before when we were doing the shifts left and right, it's opposite of what you think. Because again, that subtraction sign or that negative sign is part of the formula. So again, I'm going to compare this to the y = 3 to the x power. I'm going to get my 3 order pairs, -1, 0, and 1, and then I'm going to shift these 3 points 1 unit to the right. So again, same order pairs as before. 3 to the -1 is 1/3, 3 to the 0 is 1, 3 to the first is 3. So let me graph these 3 order pairs, and again, the graph is right here, but I'll redo it up here. So again, 0, 3, 1/3, and now I take each one of these points and I'm going to shift them 1 to the right. So to the right, to the right, to the right, and then connect them. And this would now be y = 3 to the x - 1 power. Again, you can do a table. Yes?
I'm confused on why it's inverse. Like when you add, you move to the left, and when...
Okay, so what it is just like before, like remember when it was x to the h squared plus k, this minus sign is part of the formula. So same thing here, it's 3 to the x minus, and then this shift, whatever this number is. So if it's 3 to the x plus 1, then what really went in here was a -1, and that's why it's left. Yes?
When you're plugging in like the x value like -1,
Uh-huh.
so like -1, and then with the -1 attached to it, so then it would be 3 to the power -2.
Right, and then that would be, so then the order pair that we're graphing for the new shift is going to be -1 and then 1/9. Okay, I know it's not labeled here, but then it, again, when I plugged in 0, so let's go ahead and see what these order pairs look like, because that confused some other people too. So my blue points are the shifted ones. So notice the ones that I shifted now, the points that are on my graph now for blue are now 0, 1, and 2, because I shifted it right. So if I show this, y = 3 to the x - 1, so 3 to the 0 - 1 is 3 to the -1, which is 1/3, which is what I have graphed here, 0, 1/3. When I plug in 1, 1 minus 1, this gives me 3 to the 0 power, which is 1, which is the order pair that I have graphed here, 1, 1. And then when I plug in 2, 2 minus 1, then I get 3 to the first, and I get 3. And that's the order pair 2, 0 after I shifted it. Does that make sense? So really in my shift, I don't have a -1 graphed. You see that? Because I moved it. So the 3 order pairs I have graphed are this one, which is going to be the 0, 1/3. And then I have now 1, 1, and then 2, 3. And this is indicating that my graph, it needs to look like when I'm all said and done here, is going to be a reflection across X. So when it's in front of the base, so when there's a negative in front of the base, it's a reflection across X. But again, I'm just going to do a table of values here using that function. So X equals y to the -3x, plug in -1, 0, and 1. Again, remember this negative sign is not being held with that 3. So when I go to do this, I'm going to get -1/3. -3 to the 0 gives me -1. -3 to the first gives me -3. I'll now graph these 3 order pairs. So -1, -1/3, and then 1 and 3. Again, notice I still have this horizontal asymptote at y equals 0. It's been reflected across the x-axis. Now we're going to see the exponent with the negative sign, and that'll be a reflection across the y-axis. Again, when it's just a basic function, I'm just going to plug in the -1, 0, and 1 into the function that's given to me. Next one. Yeah. Okay. So again, if the exponent has the negative sign, then our graph should look like it's been reflected across y. So again, for this one, I'm just going to plug in to my table the given equation. So -1, 0, 1. 3 to the -1 gives me 3 to the +1, which is 3. 3 to the -0 is just 1. And 3 to the -1 is 1/3. So again, take these order pairs and graph them. And again, we have our horizontal asymptote right here at y equals 0. Now we're going to do a double shift here. We're going to do an up and a down and a left and a right on our last example. Now for my basic function, I'm going to graph it I'm not going to do the reflection, the left and the down. I'm going to do the basic as the reflection, and then shift just left and right. Left and down. All right. Okay, so technically if we were to identify all of these shifts, this would be a reflection. Reflection across X. This would be a shift to left. And this would be 1 down. So what I'm going to do, instead of doing all 3 of these, I'm going to I'm going to make my table for just -3 to the x. Once I get those 3 points, I'm going to shift them 2 left and 1 down. Now, again, if you'd rather just do a table and plug it into that original thing, you can do that also. But let's go ahead and get our 3 points plugged into this function, -3 to the x. So -1, 0, and 1. So this becomes -3 to the -1, which is -1/3. -3 to the 0, and that's -1. -3 to the first, and that's -3. So let me graph these 3 points, and then I'm going to shift them two left and one down. So these 3 points, after I put them on the graph, then I'm going to move them. So I'm going to graph them originally in red. So 0, -1, 1, -3, -1, and the -1/3. Now I'm going to take these 3 points and move them two left and one down. So let me do this first one. This one right here, the -1, -1/3, 2 to the left, 1, 2, and then 1 down. Then I'll take the y-intercept, 2 left, 1 down, 2 left, 1 down. You can now see that your horizontal asymptote has shifted to now y equals -1. All right, so homework is here, 13 through 31 odd. They're all graphs. That's it.